Okay, so I decided to film the whole assembly process for this simple solar harvester device, hoping that someone will find it helpful if they want to build one too. Here's what you'll need to get started. A tube of epoxy resin with something disposable to spread it, our 3D printed parts. There is actually two of them. The yellow one houses the solar panel, and the green one serves as both backlit and the mounting surface for electronics. We're going to make the enclosure water and dust tight by coating it in two-component epoxy resin. As you can see here, I decided to act smart, quote unquote, and mix the resins directly on part. That didn't work quite as well as I expected, as it's almost impossible to get resins thoroughly intermixed when they're already coating the part. Make sure not to smear epoxy on bits that are sensitive to size change, namely the mounting hole for SP16 connector, counter bores that hide screw heads on the back lid, and flat square surface where you mount the solar panel. Now we wait for the first coat to turn completely solid. This can take upwards of 12 hours. Okay, let's try again. This time around I have a container for mixing epoxy. Apply the second coat in much the same way as the first one. Try to spread epoxy evenly across the surface because this is the last coating and you want your device to look pretty, like mine. If you've got some epoxy on your hands, it can be wiped off with the help of some rubbing alcohol and paper towels. This concludes the messy part of our work. While we're waiting, let's get the electronics ready for installation. We'll start by soldering one of the JST connectors to the solar panel. Don't forget to thin the tips of the wires beforehand. In my case, the red wire goes to the positive terminal of the panel and the black wire goes to the negative one, in accord with convention. This could be different for you, so don't forget to glance at the charger board before soldering. So another JST connector has to be soldered to the waterproof connector with two pins. It doesn't really matter which wire soldered to which pin, as long as you'll remember that afterwards. The remaining one goes to the battery holder. This is literally all we have to solder together in order to build the harvester. We can finally get to assembling it, of course provided that both enclosure related parts have dried up. As far as assembly goes, I've rendered this exploded view/assembly instructions video to aid the process. You can find this same video in Git repository, but I've also filmed my own technique, as it were. I've personally found that doing a sort of a test fit before slapping the parts together helps to handle assembly more gracefully. This is because depending on the quality of your prints and how much epoxy got into all the wrong places, you might need to file away some extras on their surface, or maybe chip off some bits. We'll start by checking if the screws fit into the lid, and that screw heads are level with the lid when it's fully inside. Repeat that for all 6 screw holes. As you can tell, some adjustments almost surely will have to be made, like expanding certain holes. Same goes for acceptable holes for screws. Now let's see if our action camera style mount can join the mating connector. I can already tell that it's all encrusted in hardened epoxy, so I'll just clean it up a bit first. Only by the time I tried to get the screw into the mounting bracket did I notice that the bolt was too close to the enclosure body. This is already fixed in the model I'm uploading to Git, but not in the part you are seeing in this video. This was a minor inconvenience that I overcame by replacing the bolt for action camera bracket with a regular one later. I'd smeared lots of epoxy on that part, and had to undertake some extensive cleaning effort. This is going to be a snug fit, which is more than appropriate for a jig that sets the angle you're only going to change once a season. Now we must get the watertight connector to fit in place. As per usual, nothing ever works on the first attempt. As soon as you've managed to push the connector into the receptacle hole, just yank it out for now. Otherwise it's going to get in our way. Finally, it's time to make use of that tiny irregular shaped part that you've printed. It's going to be holding the charger board firmly in place. While we're at it, why not screw on the battery holder? Electronics installation is the tipping point where we finally get to the actual assembly process. Once we are confident that no parts of the lid prevent the electronic parts from sitting in place, and it's a good fit, we'll leave them be. Glue in the solar panel now. It should fit tightly into the recess on the front of the yellow part. I'm using silicone adhesive for its waterproofing properties. That way we're getting not only adhesion, but also not letting any water in through the cracks. Remove any excess silicone. Now we're going to use the template to cut silicone washer to size. Evidently, I've picked the same kitchen knife for the job, although an X-Acto knife would be a better fit for this kind of precision cutting. And there you go, a wholly custom silicone washer that, when installed, will expand and contract as needed to fill all the voids between enclosure and the lid. It's time to get every other loose part in. A rubber washer that came with the connector goes on the outer side. Snap the remaining two JST connectors into place and insert the battery, in no particular order. Mind the washer, it goes between two 3D printed parts, so all of the wires must go through it. We can test the whole rig now. As sunlight strikes the panel, red LED on the board should come on. If it doesn't, check your wiring, or the electronic parts themselves might be faulty. If you are bent on efficiency, you may even desolder the LED of the board to collect and utilize more of that sweet, sweet solar energy. Trim the silicone washer around the corners, and you're now a proud owner of a low wattage outdoor solar harvester. To cap it off, measure the voltage on the pins of power connector. If it's anywhere from 3 to 4.2 volts, it's working. The reason I designed this panel to be mounted on an action cam style connector is that it allows for almost unlimited flexibility of positions you can fix the panel in. I'll link to some possible solutions in my blog post alongside with the balcony railing mount that you're seeing right now. In an unlikely case someone's balcony is identical to mine, that might also prove useful. This was all I had for today. Have fun and DIY.